Hello, skis. This is Dr. Pike coming to you live from portable number 5, if it still exists. Sometimes. Anyways, in this section, I'm going to be talking about 4 forward trig functions of any angle. Basically, it's just the same thing you guys have been doing before. There's only one little variation that I'm going to go off of. So I'm just going to jump right into examples. We have find the 6 trig function values of 5, 12. Notice, this is not a point on our unit circle, so we can't say that x is cosine and y is sine. So we actually need to draw out a triangle. So if it's 5, 12, it's over 5 up 12, so it's somewhere up here. So I have a radius, I have a triangle, so I'm over 5 up 12. You can use Pythagorean theorems to find the other side, so we'll have a 5, 12, 13 triangle. And now for my reference angle, don't forget the reference angle is on the x-axis, to the x-axis, the shortest distance to the x-axis. So if I want to find sine of theta, cosine theta, tangent theta, right, all your 6 trig values, writing them out real fast. Banana, 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 banana. What if I talked in only bananas? Would you understand what I was talking about? Banana? Banana, 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 banana. Sine theta is opposite over hypotenuse, so from your theta, you go opposite is 12, hypotenuse is 13, so opposite over hypotenuse is going to be 12 over 13. Cosecant is his brother, so you can flip that. Cosine is adjacent over hypotenuse, so 5 over 13, 5, and secant, flip cosine, so 13, come on, over 5. Tangent's opposite over adjacent, so 12 over 5. And cotangent, flip your tangent. I do not like writing 5s today. Buenissimo! Here's another example. In this case, we are given sine of theta is negative 3 over 5. We have to find the other 5 trig functions. So since I know sine, I also really know cosecant, because you flip sine for that, so I know cosecant is going to be negative 5 over 3. Well, that doesn't really help me much for all the other ones, because I don't know how to find cosine. However, I do know that sine is opposite over hypotenuse, it's negative, and this tells me it's in quadrant 3. Well, that's important because it's in quadrant 3, because if I look at my all students take calculus, then for sine to be negative, it would either have to be in quadrant 3 or 4. So since it tells me it's in quadrant 3, I'm only going to use the angle in quadrant 3. So looking at our graph, I have negative 3/5, so I'm down here somewhere. Sine is, well, here's my reference angle, right, theta prime. I can draw my triangle. Sine is opposite over hypotenuse, so then that must mean that my opposite side is negative 3 and my hypotenuse is 5. Your hypotenuse is always going to be a positive number because that is just your radius. Your radius is a positive number, so your hypotenuse should always be positive. Okay, if we don't know this other side up here, you can use your Pythagorean theorem again. And since this is going to the left, this is actually going to be a negative 4. I know you're going to find a positive 4 in your calculator, but think about it. If you have to go left 4, down 3, then shouldn't this be a negative 4? Hopefully. So if we have cosine, cosine is adjacent over hypotenuse, so adjacent is negative 4, over hypotenuse is 5, pink! So negative 4 over 5. Yeah. Can flip that for secant, so negative 5 over 4. Tangent is opposite over adjacent, so negative 3 over negative 4, which is just going to be positive 3 over 4, because negative divided by negative is a positive. Flip it for cotangent, and there we go. There's our 5 other trig functions. And yet another example for you guys. We have find all 6 trig functions, given that theta is 330 degrees. Well, first step in any of this is to figure out what quadrant we are in. 330 degrees, we have 270 is straight down, 360 is a full circle, so I know I'm going to be in the 4th quadrant, so only cosine is positive. So you can go through this, make sine negative, cosecant negative, tangent and cotangent negative if you would like to do that first. Now, this whole thing with the angle, what we're going to do is, we've gone over this before, is we are going to use our reference angle. We have 330 degrees, and a full circle is 360 degrees. So the difference between my x-axis and where my line is, where my terminal side is 30 degrees. So my reference angle then is going to be 30 degrees. So I'm going to use that 30 degrees in my triangle. So I'm going to have the triangle, see if I can do it. Oh, in the moment of truth. Yeah, kind of, sort of. So I have the 30 degrees down here. Cross is 1, square root 3, and 2. Sine is opposite over hypotenuse, so I have positive or negative 1/2. Flip it for cosecant, so it's going to be 2. Cosine is adjacent over hypotenuse, so square root 3 over 2. Secant is that flipped, so 2 root 3 over 3. After you rationalize it, make sure you rationalize. Tangent is opposite over adjacent, so 1 over root 3. So when you rationalize, it will be square root 3 over 3. And then cotangent will just be square root 3. And there you go. There's your 6 trig functions. Okay, this is the new type of example that you guys haven't seen quite yet. We did it a little bit in 4.3 with finding the angle where sine is square root 2 over 2. But now we're trying to find two solutions. Okay, and these solutions are between 0 pi and 2 pi, so I can't use terminal angles or anything like that. Well, I have sine as positive, so thinking about my quadrants, sine is positive only in the second and first quadrant, so that's what quadrants my angle must be in. I must have an angle in here, and I must have an angle somewhere up there. So I'm going to have two angles I'm going to be able to find. Now this sine is opposite over hypotenuse, and if I have square root 2 over 2, I don't have an opposite side as square root 2 in my triangles. However, if I kind of unrationalize this, then I can have an opposite over hypotenuse such that the opposite is 1, the hypotenuse is root 2, and I can use my pi over 4 triangle for that, because I have 1, 1, square root 2 as my sides. So then my angle, one of my angles, since I'm in the first quadrant, is going to be pi over 4. Don't forget that's just your reference angle. So in your triangle, we're referencing the angle pi over 4. So now, I found my one in my first quadrant, because that's just whatever it is. This one in the second quadrant, though, if I were to draw it a little bit bigger for you guys, I have something like this. My reference angle is pi over 4 to the x-axis, so that distance in there is pi over 4. Really, the angle that I want to know, though, is that angle right there. So if I want to know this, I know over to this side is pi, or if I had the same denominator, it's 4 pi over 4. Well, this is pi over 4 less to get the full angle. So if I just take away pi over 4 from the 4 pi over 4, then my other angle is going to be 3 pi over 4. If you want to check it, go for it. You can say sine of 3 pi over 4. You'll be in the second quadrant. Good. So it'll be positive, exactly what we want. And over 4, so opposite over hypotenuse will be 1 over square root 2, and we are good to go. Okay, I'm going to look at one more example in this video. And this example is just like the last one. We're finding two angles between 0 and 2 pi. I didn't write that part, but I'm lazy. So, first thing that we want to do is figure out which quadrants we are in. We have all students take calculus, or all sombreros try chimichangas, or calypsos, or all Somalians take, I don't know. You can make something up. However you want to remember it, doesn't matter. So if I want to have the quadrants where cosine is negative, that is this quadrant and this quadrant. So over here they're all positive, and down here cosine is positive. So I know I'm going to be in quadrants 2 and 3. So since I'm going to be in quadrants 2 and 3, the next thing I'm going to do is figure out my reference angle. Cosine is adjacent over hypotenuse, so I know I'm going to have my adjacent side is square root 3, my hypotenuse is 2. Well, that's in our 30, 60, 90 triangle. Pi over 6, pi over 3, square root 3 over 1 and 2. Square root pi over 3. So adjacent has to be square root 3. The hypotenuse has to be 2. Well, that means pi over 6 is my reference angle. So I'm going to use that pi over 6 to figure out both of these quadrant angles. My one in the second quadrant will be somewhere up here, and that will be pi over 6 inside of there. Well, if 1 pi is 6 pi over 6, then I have one less with that to get my angle here. So that means my first angle is going to be 5 pi over 6. If I can draw it. There we go. Then this next one is going to be down below that. So again, since this is 6 pi over 6, and my reference angle is pi over 6, I can just add this pi over 6 to get the complete angle from the positive x-axis, which will be 7 pi over 6. And there are our two angles. If you want, again, you can check it out. Plug in cosine of 5 pi over 6 and cosine of 7 pi over 6. As always, thank you guys for watching, and I hope you have a wonderful rest of your day, however much of that you have.